This video discusses how to find the symmetry from an equation. And we've already done symmetry from a graph. Remember, there's two types of symmetry we talk about. So we call even symmetry. And even symmetry is symmetric through the y-axis. And we also have odd symmetry. And odd symmetry is symmetric from the origin. And all that means is that in an even graph, for instance, if you have a point like this over here, where we're at -4 here, -4, 15, we should also have the point 4, 15. So notice this, the point -4, 15 is 4, 15 over here, where both the y values are the same. The only thing that changes is you have opposite x's. In an odd function, you have the point 4, 75 here, and the point -4, -75 here. And so notice, again, different y, opposite y's and opposite x's. So that's what makes this even and odd work. So when we talk about even symmetry, by definition, if we let the input be x and the output be f of x, we can see that if we write something like this right here, this is saying that your x, when you have a negative x plugged in, it should give you the same thing as a positive x. And what I mean by that is, this is the y value, this is the y value. It's telling me that when I plug in negative x, or if I plug in positive x, I get the exact same thing, which is what this is saying. I plugged in a negative x here and got 15, plugged in a positive x here and got 15. So basically what this means is that in even symmetry, you get the same y values. And then in odd symmetry, you take negative x, plug in positive x, and notice this time you're going to get a negative y value. So what this is saying, and if you look up the graph again, we plugged in a positive x, got a positive, plugged in negative x, got a negative. If you look at just your y values, though, your y values switch when your x is switched. So here you get opposite y values. Now, we could go through plugging in negative x for everything and seeing what we got back out. And I'll actually do the first one like that. But a much simpler process and a much simpler way to do this is to just plug in 1 and -1 and evaluate to see if the same y values are opposite y values. So if we look at the first one, if we were to take this and plug in this function and plug in f of -x, we would get this, -2, and this says for every x, plug in -x. So for every x here, I'm going to plug in -x. So I get -2 times -x squared minus 3. When I evaluate this, this becomes -2, -x squared. Anytime you square a negative number, it becomes positive. So this becomes -2x squared minus 3. Notice here, I'm getting the exact same value, the exact same function that I started with after evaluating for -x. Because of that, this tells me this is an even function. So this is an even function because I get the exact same y value. Now, this may be difficult for you to understand or see, so a much easier way to do this is to evaluate the function at two values. In particular, we're going to evaluate at f of 1. So evaluate at f of 1, I get this, -2. I'm going to plug in this 1 for every x up here. So -2 times 1 squared minus 3. When I do that, 1 squared is 1. -2 times 1 is -2 minus 3. That equals -5. Do the exact same thing, except this time plug in -1. So notice I'm plugging in opposite x's. First part of the definition says to plug in opposite x's, and then evaluate your y's. So here I'm going to do -2 times -1 squared minus. So when I evaluate this equation, again, I'm going to get -1 squared. That's +1 times a negative 2 is a negative 2 minus 3 is negative 5. I get the exact same y values when I plug in 1 and negative 1. So again, because I get the same y values, that tells me that this function is also an even function. Look at the next one. Plug in f of 1 first. So we get 4 times 1 squared minus 2 times 1 plus 6. 1 squared is 1. 4 times 1 is 4. 2 times 1 is negative 2 plus 6. 4 minus 2 plus 6 is equal to positive 4. Evaluate at f of negative 1. That's 4 times negative 1 squared minus 2 times negative 1 plus 6. Negative 1 squared is 1 times 4 is 4. Negative 2 times negative 1 is a positive 2 plus 6. So that's 4 plus 2 plus 6. That's equal to 12. If we compare the values 4 and 12, two questions I want to ask. Are they the same y values? No. Are they opposite y values? No, they're totally different. That makes this a neither. So it's neither even or odd. The last one. F of 1 is 2 times 1 cubed minus 3 times 1. F of negative 1 is 2 times negative 1 cubed minus 3 times 1 times negative 1. So again, when I evaluate both equations, the first one, 1 cubed is 1 times 2 is 2, and that's 2 minus 3, negative 1. Here, negative 1 cubed is a negative 1 times 2 is a negative 2. So this part is negative 2. And then negative 3 minus negative 3 times the negative 1 is a positive 3. Negative 2 plus 3 equals positive 1. If we compare the y values, they're not the same y values, but they are opposite y values. Because they're opposite y values, that makes this an odd function. So when you look at symmetry from an equation, if you plug in 1 and negative 1, same y values, it's even. If you get opposite y values, it's odd. If you get different y values, it's going to be neither.